Welcome to Tech with Kaushik. This is part 1 of our complete practice question series for the AZ-104 Microsoft Azure Administrator exam. Test your knowledge with exam-focused questions covering key Azure administration concepts. Choose your answer before the timer ends, then review the correct answer, clear explanation, and practical exam tip. Let us begin part 1. Now consider question number 1. This one tests your understanding of load balancer troubleshooting. Scenario: you deploy an Azure Standard Public Load Balancer named EXTLB01. The load balancer distributes HTTP traffic across a backend pool containing 6 Ubuntu Linux virtual machines. A newly deployed web application requires that a user session remains on the exact same backend virtual machine for the duration of their interaction, based strictly on their source IP address. Which load balancer setting should you modify to achieve this requirement? The options are: Choice A, change the load balancing rule protocol to UDP. Choice B, set the session persistence setting to client IP. Choice C, enable floating IP, direct server return. Choice D, configure a more aggressive health probe interval. The appropriate choice is option B, set the session persistence setting to client IP. Here is the technical justification. Setting session persistence to client IP instructs the Azure Load Balancer to use a 2-tuple hash, source IP and destination IP, to route all requests from a specific client to the same backend pool instance. A. Changing the protocol to UDP breaks HTTP traffic, which requires TCP, and does not govern session stickiness. C. Floating IP is used for specific backend configurations like SQL always-on or multiple endpoints sharing an IP, not for user session stickiness. D. Health probes determine backend health status, not client routing persistence. Remember this distinction for the exam. Azure Load Balancer session persistence options include none, 5-tuple, client IP, 2-tuple, and client IP and protocol, 3-tuple. We will now analyze question number 2. Consider the following scenario. An organization manages a web tier consisting of 4 Azure virtual machines running IIS. An internal Azure load balancer distributes traffic to the virtual machines. You must ensure that incoming traffic from the same client IP address and the same transport protocol is always directed to the same IIS server. Which configuration adjustment should you make to the load balancing rule? Now examine the possible answers. Choice A, change the session persistence configuration to client IP and protocol. Choice B, disable floating IP, direct server return. Choice C, set session persistence to none. Choice D, change the transport protocol to UDP. In this case, select option A, change the session persistence configuration to client IP and protocol. The reasoning is as follows. Client IP and protocol uses a 3-tuple hash based on source IP, destination IP, and protocol, keeping traffic that matches those values on the same backend instance. The alternatives can be eliminated because B, floating IP changes packet addressing behavior and does not configure affinity. C, none uses the default 5-tuple distribution and does not provide the requested persistence. D, changing the rule to UDP would not satisfy an HTTP/TCP workload and does not configure affinity. Keep this examination point in mind. Client IP uses a 2-tuple hash, client IP and protocol uses a 3-tuple hash. Neither mode uses the client source port. Question number 3. Review the situation. Your company plans to deploy a high-performance Azure file share named AppData in a new storage account named StoreAlpha. The application requires SMB multi-channel for parallel connections. You must minimize storage cost while meeting this requirement. Which storage account configuration should you provision? Review the options. Option A, standard performance with locally redundant storage, LRS. Option B, standard performance with zone redundant storage, ZRS. Option C, premium performance with locally redundant storage, LRS. Option D, premium performance with geo-redundant storage, GRS. The correct answer is option C, premium performance with locally redundant storage, LRS. The requirement is satisfied because SMB multi-channel is supported on SSD, premium, Azure file shares. Premium LRS meets the feature requirement and is less costly than premium ZRS. Now consider why the remaining options are unsuitable. A and B, standard HDD file shares do not support SMB multi-channel. D, premium file storage accounts do not support GRS, SSD file shares support LRS or ZRS. Exam tip. SMB multi-channel is available for SSD Azure file shares. Choose LRS when premium capability is required and cost is the deciding factor. Proceed to question number 4. An Azure subscription named Subcorp contains a resource group named NetRG. NetRG contains a virtual network named CoreVNet. Admin 1 currently has Reader, Security Admin, and Security Reader at the subscription scope. You must allow Admin 1 to assign the Reader role to other users only for CoreVNet while following least privilege. What should you do? Available choices. Choice A, assign Admin 1 the contributor role at the CoreVNet scope. Choice B, assign Admin 1 the role-based access control administrator role at the CoreVNet scope. Choice C, assign Admin 1 the contributor role at the NetRG scope. Choice D, assign Admin 1 the network contributor role at the NetRG scope. The best answer is option B, assign Admin 1 the role-based access control administrator role at the CoreVNet scope. The role-based access control administrator role is designed for delegating Azure RBAC assignment management and has fewer permissions than user access administrator. Scoping it to CoreVNet limits the delegation to that resource. The incorrect choices fail for the following reasons. A, C, and D. Contributor and network contributor can manage resources but cannot create Azure role assignments. The resource group options also grant broader scope than required. Use role-based access control administrator for least privilege RBAC delegation. Scope the assignment to the smallest required resource. The next item is question number 5. We are moving to Azure Bastion. Consider this scenario. You manage a virtual network named HubVNet and an Azure Bastion host named Bastion Host that uses the basic SKU. A Windows Server 2022 VM named AppVM is in HubVNet and has no public IP address. From a Windows 11 workstation with Azure CLI installed, you must connect to AppVM by using the native mstsc.exe client through Bastion. Which 3 actions must you perform in sequence? Review the items to be ordered. The first available item is from Bastion Host Settings, enable Kerberos authentication. The second available item is upgrade Bastion Host to the standard SKU. The third available item is from the Azure CLI on your workstation, run AZ Network Bastion RDP. The fourth available item is from AppVM, enable just-in-time, JIT, VM access. The fifth available item is from Bastion Host Settings, enable native client support. Arrange the items in this order. First, upgrade Bastion Host to the standard SKU. Second, from Bastion Host Settings, enable native client support. Third, from the Azure CLI on your workstation, run AZ Network Bastion RDP. This is correct because native client connections require the standard SKU or higher. After upgrading, enable native client support and then run AZ Network Bastion RDP from the local workstation. A useful examination rule is this. Browser connections work with lower Bastion SKUs, but native RDP or SSH through Azure CLI requires standard or higher with native client support enabled. Proceed to question number 6. Scenario. A storage account named Store123 contains an SMB file share named Finance Share. You need the storage file data SMB share contributor role assigned to a Microsoft entry user named Smith to provide share-level SMB permissions. What must be configured on Store123 before the role can provide SMB access? Option A. Enable an identity source for Azure Files authentication. Option B. Configure access control, IAM, at the blob container level. Option C. Allow Microsoft enter traffic through the storage firewall. Option D. Set Microsoft Entra authorization as the default for blob service requests. The required response is Option A. Enable an identity source for Azure Files authentication. The key reason is Azure Files SMB identity-based access requires one supported identity source on the storage account, such as ADDS, Microsoft Entra Domain Services, or Microsoft Entra Kerberos. Share-level RBAC permissions are configured after that identity source is enabled. The other choices do not satisfy the requirement because B. Blob Container IAM is unrelated to an Azure file share. C. Firewall rules control network reachability, not SMB identity integration. D. Default authorization for blob service requests does not enable SMB authentication for Azure files. The key takeaway is for SMB identity access, enable one identity source, assign a share-level Azure RBAC role, and then configure file and directory ACLs as needed. Review question number 7. Carefully. This question moves us into AZ copy. Let us first review the situation. You must copy a 4 TB directory tree from an on-premises Windows server to an Azure Blob container. The transfer must be scriptable, support SAS authentication, preserve the directory hierarchy, and allow a failed job to be resumed. Which tool should you use? Compare the following options. Option A is Azure Storage Explorer. Option B is AZ Copy. Option C is Azure File Sync. Option D is Azure Import Export. The appropriate choice is option B, AZ Copy. Here is the technical justification. AZ Copy is a command-line data transfer utility optimized for copying data to and from Azure storage. It supports SAS authentication, recursive directory copies, job logging, and job resume. The remaining options are incorrect because A. Storage Explorer is a graphical management tool rather than the best choice for a large scripted transfer. C. Azure File Sync synchronizes Windows Server with Azure Files, not a blob container. D. Import-Export uses shipped disks and is not the requested online scripted transfer. Remember this distinction for the exam. Use AZ Copy for high-performance scripted transfers involving Azure Blob Storage or Azure Files. Use Storage Explorer for interactive GUI management. Let us work through question number 8. Review the scenario carefully. An administrator must use a Windows desktop application to sign in with Microsoft Entra ID, browse several Azure storage accounts, upload and download blobs and files, and copy data interactively between supported storage resources. Which tool should the administrator use? Choose from the following options. Option A is Azure Storage Explorer. Option B is Azure File Sync. Option C is Azure Import Export. Option D is Azure Backup. The required response is option A, Azure Storage Explorer. The reasoning is as follows. Azure Storage Explorer is a desktop GUI for managing Azure storage data, including blobs, file shares, queues, and tables, with Microsoft Entra and other supported authentication methods. B. Azure File Sync synchronizes Windows Server file data with Azure Files. C. Import-Export transfers data by shipping disks. D. Azure Backup protects supported workloads and is not an interactive storage browser. Keep this examination point in mind. Use Storage Explorer for interactive GUI administration. Use AZ Copy when automation and high-throughput command-line transfers are required. Question number 9. Now, you manage an Azure subscription and plan to implement fine-grained access controls on a storage account named Sextor99. You intend to use attribute-based access control, ABAC, by adding conditions to role assignments. Which storage services within Sextor99 support conditions and role assignments? Options. Option A, blob containers only. Option B, file shares only. Option C, blob containers and queues only. Option D, file shares and tables only. In this case, select option C, blob containers and queues only. The requirement is satisfied because Azure Attribute-Based Access Control, ABAC, conditions for Azure Storage currently support only Azure Blob Storage, Containers and Blobs, and Azure Queue Storage. The alternatives can be eliminated because A, while blob containers are supported, queues are also supported, making this option incomplete. B and D, ABAC role assignment conditions are not currently supported for Azure Files or Azure Tables. Exam tip. Azure ABAC builds on Azure RBAC by adding conditions. For storage, remember it strictly applies to data actions for blobs and queues. The next item is question number 10. The focus now shifts to role assignment scope. A resource group named RGProd contains a virtual network named VNetProd. Chris currently has Reader, Security Admin, and Security Reader at the subscription scope. You must allow Chris to grant the Reader role to external auditors only on VNetProd while following least privilege. What should you do? Available choices. Option A. Assign Chris the contributor role on RGProd. Option B. Assign Chris the role-based access control administrator role on VNetProd. Option C. Assign Chris the network contributor role on RGProd. Option D. Assign Chris the contributor role at the subscription scope. The correct answer is option B. Assign Chris the role-based access control administrator role on VNetProd. This role is intended for Azure RBAC delegation and has fewer permissions than User Access Administrator. Assigning it directly on VNetProd confines the authority to the required resource. Now consider why the remaining options are unsuitable. A, C, and D. Contributor and network contributor can modify resources but cannot assign Azure roles. The resource group and subscription scopes are also broader than required. For least privilege access delegation, use role-based access control administrator at the narrowest required scope. Question number 11. Requires careful analysis. Analyze the scenario before evaluating the choices. You operate an Azure load balancer named LBWeb that distributes internet traffic to 5 Windows Server virtual machines functioning as web servers. A stateful application hosted on the virtual machines dictates that a user session must always be serviced by the same backend VM on every subsequent request. Which load balancer configuration should you implement? Evaluate each option against the stated requirement. Consider option A. Enable floating IP, direct server return. Consider option B. Set session persistence to client IP. Consider option C. Change the protocol to UDP. Consider option D. Set the idle timeout, minutes, to 20. The best answer is option B. Set session persistence to client IP. This is correct because configuring session persistence to client IP ensures that the load balancer uses the source IP of the client to continually route their traffic to the same backend web server. The incorrect choices fail for the following reasons. A. Floating IP allows backend servers to respond with the load balancer's IP, it does not control session stickiness. C. Changing to UDP breaks web, HTTP/TCP, traffic. D. Idle timeout determines how long a TCP connection is kept open without activity, not which backend VM processes new requests from the client. A useful examination rule is this. Azure Load Balancer defaults to a 5-tuple hash which does not maintain session affinity. You must explicitly configure session persistence, client IP or client IP and protocol, to achieve stickiness. Now consider question number 12. Review the situation. A Microsoft Entra tenant contains a management group named MGHQ Sub-East and Sub-West are under MGHQ Sub-East contains AppRG, which contains 5 Azure Logic apps. AdminX is a member of SEC Group 1. At the MGHQ scope, SEC Group 1 has Reader and AdminX has User Access Administrator. AdminX also has Virtual Machine Contributor on both subscriptions. For each statement, select Yes if the statement is true. Otherwise, select No. Review Statement 1. Members of SEC Group 1 can view the configurations of the Azure Logic apps in AppRG. Review Statement 2. AdminX can assign the owner role to another user for AppRG. Review Statement 3. Admin X can create a new resource group in Sub-East and deploy a virtual machine into it. Statement 1. The answer is yes. Reader assigned at the management group scope is inherited by the subscriptions, resource groups, and resources below it. Statement 2. The answer is yes. User Access Administrator at MGHQ is inherited by AppRG and permits role assignment management there. Statement 3. The answer is no. Virtual Machine Contributor can manage virtual machines but does not include permission to create resource groups. The key takeaway is always evaluate effective access from all inherited and direct assignments. Resource-specific contributor roles do not automatically include resource group management. Question number 13. Consider this scenario. An Azure subscription contains these virtual networks: VNet A, Resource Group DebRG, Region East US, Subnet A10.1.0.0/16 VNet B, Resource Group QARG, Region Central US, Subnet B10.2.0.0/24 VNet C, Resource Group ProdRG, Region West US, Subnet C10.3.0.0/24. You plan to deploy VM1 in East US, VM2 in East US, and VM3 in West US. VM2 will be created in QARG. For each statement, select yes if the statement is true. Otherwise, select no. The first statement is, you can deploy VM1 in East US and attach its network interface to Subnet B in VNet B. The second statement is, you can deploy VM2 in QARG and attach its network interface to Subnet A in VNet A. The third statement is, you can deploy VM3 in West US and attach its network interface to Subnet C in VNet C. The answer to statement 1 is no. A VM network interface must be connected to a virtual network in the same Azure region as the VM. The answer to statement 2 is yes. A VM and its virtual network can be in different resource groups, provided the regional and permission requirements are met. The answer to statement 3 is yes. VM3 and VNet C are both in West US, and the /24 subnet has sufficient addresses for the deployment. Remember this distinction for the exam. For VM networking, region alignment is mandatory. The VM, NIC, and VNet may be organized in different resource groups. Question number 14. The difficulty level here is easy. You are preparing an Azure storage account for sensitive documents. The account must use a customer-managed key stored in Azure Key Vault, and the key must use the maximum supported bit length. Select the key type and bit length that meet the requirements. Choose the correct entry for every drop-down field. Statement 1. Key type, the blank. Select from 1. AES, 3DES, or RSA. Statement 2. Bit length, the blank. Select from 2. 2048, 3072, 4096, or 8192. The answer to the first statement is RSA. Azure Storage Customer Managed Keys stored in Key Vault use RSA or RSAHSM keys. The answer to the second statement is 4096. 4096 bits is the maximum supported RSA key size among the listed choices. Keep this examination point in mind. For Azure Storage CMK, use an RSA or RSAHSM key and ensure the vault has soft delete and purge protection enabled. The next key item is question number 18. This scenario establishes the key requirement. You are configuring an Azure Bastion deployment using the basic SKU to securely access virtual machines in your subscription. You have the following public IP resources available: PIP1, IP version 4, standard SKU, regional, static PIP2, IP version 4, standard SKU, global, static PIP3, IP version 4, basic SKU, regional, dynamic PIP4, IP version 4, basic SKU, regional, static PIP5, IP version 6, standard SKU, regional, static. Which of these public IP addresses can be attached to the Azure Bastion host? Focus on the distinction between these options. Option A, PIP1 only. Option B, PIP1 and PIP2 only. Option C, PIP3, PIP4, and PIP5 only. Option D, PIP1, PIP2, PIP4, and PIP5 only. In this case, select option A, PIP1 only. The key reason is Azure Bastion requires a public IP address that is IP version 4, uses the standard SKU, and has a static assignment. Global tier public IPs and IP version 6 are not supported. Only PIP1 meets all these constraints. The other choices do not satisfy the requirement because B, PIP2 is a global tier IP, which Bastion does not support, it requires a regional IP. C and D, PIP3 and PIP4 use the basic SKU, which is incompatible with Bastion. PIP5 is IP version 6, which is also unsupported. Exam tip. Azure Bastion always requires a standard SKU, static, IP version 4, regional public IP address. Basic SKU IPs cannot be attached. The next item is question number 19. Review the situation. An Azure environment contains two subscriptions, Sub-Alpha and Sub-Beta. Sub-Alpha hosts a resource group containing an Azure virtual machine named SRV Data, its operating system managed disk, OS disk data, and its network interface, NIC data. NIC data is connected to a virtual network named Core VNet. A separate storage account named bootdiagstore holds only boot diagnostic logs. You must relocate SRV data to Sub-Beta. Which resources are required to be moved to Sub-Beta simultaneously? The options are: Choice A, SRV data, OS disk data, and NIC data only. Choice B, SRV data, OS disk data, NIC data, and Core VNet. Choice C, SRV data, OS disk data, and bootdiagstore only. Choice D, SRV data, OS disk data, and Core VNet only. The appropriate choice is option B, SRV data, OS disk data, NIC data, and Core VNet. Here is the technical justification. When moving an Azure virtual machine to a new subscription, you must also move all its directly dependent resources. This strictly includes its disks and network interfaces. Crucially, a network interface cannot be moved to a different subscription independently of the virtual network it connects to, therefore, the VNet must also move. The remaining options are incorrect because A and D. If you try to move a NIC across a subscription boundary without its connected VNet, the move operation will fail. C. While boot diagnostic storage can be moved, it is not a strict requirement, whereas the NIC and VNet must go with the VM. When moving virtual machines between subscriptions, dependent resources, NICs, disks, must move together. Because a NIC cannot span subscriptions with its VNet, the VNet must move alongside the NIC. Question number 20. Highlights an important distinction. Focus on the following situation. An Azure Public Load Balancer distributes HTTP requests across multiple backend web servers. The web servers run a legacy application that relies on maintaining application state locally. You need to guarantee that once a client establishes a connection, all their subsequent requests are handled by the same web server. Which parameter on the load balancing rule must you alter? The relevant choices are as follows. Now examine choice A, change floating IP, direct server return, to enabled. Now examine choice B, modify session persistence to client IP. Now examine choice C, configure a dedicated TCP health probe. Now examine choice D, change floating IP, direct server return, to disabled. The required response is option B, modify session persistence to client IP. The reasoning is as follows. To ensure requests from the same client are persistently routed to the exact same backend server, session persistence must be set to client IP, or client IP and protocol. A and D, floating IP is a feature for SQL always-on and highly specific high-availability configurations. It does not control user session persistence. C. A health probe manages backend availability tracking, not client-to-server routing affinity. A useful examination rule is this. To achieve sticky sessions at the network layer in Azure Load Balancer, always adjust the session persistence configuration away from none. Proceed to question number 21. This is an easy level challenge. Scenario. You deploy 5 Azure virtual machines hosting a multi-tier application. An Azure Load Balancer is configured to evenly distribute incoming traffic to these virtual machines. Users report that their shopping cart contents drop unexpectedly. You determine this happens because their requests are hitting different backend virtual machines. What is the proper load balancer configuration to resolve this issue? Review the options. Choice A. Enable floating IP, direct server return. Choice B. Set the idle timeout, minutes, to a higher value. Choice C. Set session persistence to client IP. Choice D. Attach a highly sensitive health probe. The best answer is option C. Set session persistence to client IP. The requirement is satisfied because dropping sessions across requests is a symptom of standard 5-tuple load balancing where requests hit different servers. Setting session persistence to client IP ensures all traffic from a user is sticky and hits the same server, preserving local state. The alternatives can be eliminated because A. Floating IP changes how the destination IP is rewritten, which is used for database routing, not web session stickiness. B. Idle timeout prevents TCP connections from dropping early, it does not route subsequent new requests to the same server. D. A health probe determines backend health status. The key takeaway is shopping cart resets or lost local application state behind an Azure Load Balancer almost always requires configuring session persistence, client IP. Now consider question number 23. Consider this scenario. You manage an Azure subscription and utilize a recovery services vault named ProdVault for VM backups. To protect against malicious deletion of backups, you must implement multi-user authorization, MUA. This requires that any critical operation on ProdVault must be approved by a separate security administrator. Which Azure resource must you create first to establish this capability? Option A. A resource guard. Option B. An administrative unit. Option C. A custom Azure role. Option D. A managed identity. The correct answer is option A. A resource guard. Multi-user authorization, MUA, for Azure Backup leverages a resource guard to act as a secondary authorization mechanism. Critical operations, like deleting backups, must be authorized by a user with permissions on the resource guard, separating duties. Now consider why the remaining options are unsuitable. B. Administrative units are used in Microsoft Entra ID to scope user and group management, not to secure recovery services vault data planes. C. While Azure roles control access, MUA specifically requires a resource guard resource to hold the secondary authorization lock. D. A managed identity provides identity to a resource but does not enforce a multi-user approval mechanism. Remember this distinction for the exam. When implementing multi-user authorization, MUA, for an Azure Recovery Services Vault, always deploy a resource guard, preferably in a separate subscription or tenant, first. Now consider question number 26. Next, we enter the topic of external user management. You administer a Microsoft Entra tenant for Fabricam.com. ICSV file contains 500 external contractors who require B2B guest access. Proposed solution: a PowerShell script loops through the CSV and calls new MG user with a tenant user principal name and password profile for each contractor. The script does not call the invitation API. For the statement, select yes if it is true. Otherwise, select no. Statement 1. The proposed PowerShell solution creates the required external guest accounts. Statement 1 should be marked no. The script creates tenant-managed user accounts rather than sending Microsoft Entra B2B invitations for the external email addresses. Keep this examination point in mind. Use new MG invitation for B2B guests, Use new MG user for accounts that the tenant creates and manages directly. Let us examine question number 27. Begin by examining the scenario. An organization uses Microsoft Entra Connect. The accounts are Alice, cloud-only member Bob, on-premises synchronized member Charlie, cloud-only guest. You must update the job title and usage location properties. Select the users whose properties can be modified directly in Microsoft Entra ID. Complete each statement by selecting the appropriate value. Review Statement 1. Job title can be modified directly in Microsoft Entra ID 4, the blank. The available choices are 1. Alice only, Alice and Charlie only, or Alice, Bob and Charlie. Review Statement 2. Usage location can be modified directly in Microsoft Entra ID 4, the blank. The available choices are 2. Alice only, Alice and Charlie only, or Alice, Bob and Charlie. Statement 1 should be completed with Alice and Charlie only. Job title for the synchronized user is mastered on premises. Cloud-only member and guest properties can be edited in Microsoft Entra ID. Statement 2 should be completed with Alice, Bob, and Charlie. Usage location is cloud managed because it is required for license assignment, including for synchronized users. Exam tip. For synchronized users, edit source authoritative profile attributes on premises. Cloud licensing properties such as usage location remain editable in Microsoft Entra ID. Let us focus on question number 28. Next, we enter the topic of storage encryption. The central scenario is as follows. You provision an Azure storage account named DataStore88. To meet strict data isolation requirements, you configure an encryption scope named Isolated Scope to manage encryption keys at a granular level rather than at the account level. Which storage service types can utilize the Isolated Scope encryption scope? The relevant choices are as follows. Option A, blob containers only. Option B, file shares only. Option C, file shares and blob containers only. Option D, blob containers, file shares, tables, and queues. The appropriate choice is option A, blob containers only. This is correct because encryption scopes in Azure Storage are designed specifically for Azure Blob Storage. They allow you to define encryption at the container level or for individual blobs, but they do not apply to Azure files, tables, or queues. The incorrect choices fail for the following reasons. B, C, and D, Azure files, tables, and queues do not support granular encryption scopes. They are encrypted uniformly using the storage account's encryption settings, Microsoft managed or customer managed keys. Encryption scopes provide multi-tenant or multi-project data isolation strictly for blob storage by allowing different keys for different containers or individual blobs. We will now analyze question number 29. Consider the following scenario. A shared Azure storage account contains 10,000 blobs. You must ensure that HR users can read only blobs whose blob index tag is department equals HR. What should you configure? Review each available choice. Choice A, a condition on an Azure role assignment. Choice B, a stored access policy. Choice C, a shared access signature for each user. Choice D, an immutable storage policy. In this case, select option A. A condition on an Azure role assignment. The key reason is Azure ABAC extends Azure RBAC by adding conditions that can evaluate supported blob attributes, including blob index tags, before a data action is authorized. The other choices do not satisfy the requirement because B, stored access policies manage service SAS constraints, not tag-based Azure RBAC authorization. C, SAS tokens do not dynamically filter access by blob index tag for each request. D, immutability prevents modification or deletion and does not filter read access. A useful examination rule is this. Use Azure role assignment conditions when blob storage access must depend on supported resource attributes such as blob index tags. Question number 30. This question moves us into app service plans. Consider this scenario. You must create an Azure App Service app named Sales App. It must use the custom domain sales.contoso.com, automatically scale out to as many as 6 instances based on CPU utilization, and minimize hosting cost. Select the minimum pricing tier and the DNS record type used to verify domain ownership. Select the value that correctly completes each statement. For the first statement, pricing plan, the blank. Choose between 1. Free, shared, basic, or standard. For the second statement, record type, the blank. Choose between 2. A, TXT, PTR, or SRV. For statement 1, select standard. Standard is the lowest listed tier that supports autoscale and more than 3 instances. For statement 2, select TXT. An Azure TXT record can verify ownership of the custom domain without directing application traffic. The key takeaway is basic supports custom domains and manual scale, while standard adds autoscale, deployment slots, and higher instance counts. Proceed to question number 31. Scenario. You manage a Microsoft Entra tenant for wingtiptoys.com. ICSV file contains 500 external vendors who need B2B guest access to an enterprise application. Proposed solution: a PowerShell script loops through the CSV and calls new MG invitation for each external email address. For the statement, select yes if it is true. Otherwise, select no. Review statement 1. The proposed PowerShell solution creates the required external guest accounts. For the first statement, choose yes. New MG invitation creates a Microsoft Entra B2B invitation and the corresponding guest object for the invited external identity. Remember this distinction for the exam. For bulk guest onboarding, iterate through the external addresses and call new MG invitation, configure invitation redemption behavior as required. The next item is question number 32. Review the situation. An Azure Standard Load Balancer distributes traffic to 5 Linux web servers. User sessions are moving between servers. You must keep traffic with the same client IP address and the same transport protocol on one backend server. Which load balancer setting should you configure? Available choices. Choice A: Session Persistence, none. Choice B: Floating IP, enabled. Choice C: Session Persistence, Client IP and Protocol. Choice D: a longer idle timeout. The required response is option C: Session Persistence, Client IP and Protocol. Here is the technical justification. Client IP and Protocol uses source IP, destination IP, and protocol for affinity, which satisfies the stated requirement. The remaining options are incorrect because A. None uses the default 5-tuple distribution. B. Floating IP controls destination address handling, not affinity. D. Idle timeout affects inactive connections and does not select the backend for later connections. Keep this examination point in mind. Client IP and Protocol does not include the client source port, it is a 3-tuple affinity mode. Question number 33. An organization hosts a PHP application on 5 Azure virtual machines. An Azure public load balancer sits in front of the virtual machines. The application requires session affinity, ensuring that a user's web browser is always serviced by the exact same web server for every web request based on their IP address. Which setting on the Azure load balancer provides this capability? The options are: Option A: Session Persistence to Client IP. Option B: Idle timeout, minutes, to 30. Option C: Session Persistence to none. Option D: Health Probe Protocol to TCP. The best answer is option A: Session Persistence to Client IP. The reasoning is as follows. Setting session persistence to client IP forces the load balancer to route all traffic originating from a specific client IP address to the same backend virtual machine for the life of the session. B. Modifying the TCP idle timeout affects connection duration, not routing destination. C. A setting of none enables 5-tuple hashing, meaning new connections from the same IP can land on any server. D. Health probes determine server availability, not client session stickiness. Exam tip. Azure Load Balancer relies on distribution modes to handle session stickiness. Client IP maps a 2-tuple hash, source IP, destination IP, to a static backend node. The next item is question number 34. Review the situation. A production Azure environment contains 5 virtual machines acting as web nodes behind an Azure Load Balancer. Users authenticate via a web form, but they frequently complain of being inexplicably logged out while navigating between pages. Application logs indicate their session tokens are invalid because their traffic is being bounced between different backend web nodes. What load balancer rule adjustment will fix this session bouncing behavior? Review the options. Option A. Change floating IP, direct server return, to disabled. Option B. Configure a custom health probe threshold. Option C. Change session persistence to client IP. Option D. Increase the idle timeout, minutes, to 15. The correct answer is option C. Change session persistence to client IP. The requirement is satisfied because inexplicable logouts behind a load balancer are a classic symptom of lost session affinity. Configuring session persistence to client IP ensures a given user is routed to the exact same web server on every request. The alternatives can be eliminated because A. Floating IP defaults to disabled and governs destination IP preservation for specialized high-availability clustering, not session stickiness. B. Health probes only exclude dead nodes from the pool. D. Idle timeout manages connection lifespan, not subsequent request routing. Default load balancing, none, distributes requests evenly. To fix localized session state loss, change the distribution mode to client IP. Review question number 35. Carefully. Let us first review the situation. You plan to attach a 2 TB data disk to an Azure VM that hosts a read-intensive transaction database. The disk must remain available after a data center level failure, provide premium performance, and avoid acknowledged database writes being held only in host write cache. Select the disk redundancy and host caching configuration. Review each blank and choose the most appropriate option. The first statement reads, storage type, the blank. The options for this statement are 1. Premium SSD with locally redundant storage, LRS, Premium SSD with zone redundant storage, ZRS, or Standard SSD with locally redundant storage, LRS. The second statement reads, host caching, the blank. The options for this statement are 2. None, read-only, or read/write. The correct value for statement 1 is Premium SSD with zone redundant storage, ZRS. Premium SSD ZRS synchronously replicates the managed disk across availability zones and provides premium disk performance. The correct value for statement 2 is read-only. Read-only caching can improve reads while database writes bypass the host cache and go to the managed disk. A useful examination rule is this. Use read-only caching for read-heavy database data disks when supported. Avoid read/write caching when the workload requires durable write ordering. Now consider question number 36. This question focuses on managed disks. Consider this scenario. An organization will enable Azure Disk Encryption on Azure virtual machines so that BitLocker or dmcrypt encrypts the OS and data volumes. A key encryption key, KEK, will be stored in a key vault named AppVault. Which 2 configurations are required on AppVault for this KEK-based setup? Select 2. Identify all valid responses. Choice A. Enable Azure virtual machines for deployment. Choice B. Create or import a key. Choice C. Create a secret manually. Choice D. Enable Azure Disk Encryption for volume encryption. Choice E. Configure a key rotation policy. Select option B. Create or import a key and option D. Enable Azure Disk Encryption for volume encryption. A KEK must exist as a key vault key, and the Vault Advanced Access policy must allow Azure Disk Encryption for volume encryption. Now consider why the remaining options are unsuitable. A. VM deployment access is used for deployment scenarios and is not the required ADE volume encryption permission. C. ADE manages the volume encryption secret, you do not create it manually as this prerequisite. E. Rotation can be configured but is not required to enable ADE. The key takeaway is for ADE with a KEK, configure the vault for disk encryption and provide a key. Deployment access is a separate optional key vault setting. Let us examine question number 37. Review the scenario carefully. Your Azure subscription contains a virtual network named Secure VNet. Multiple virtual machines reside in Secure VNet without public internet access. You plan to enable Azure Monitor VM Insights to monitor their performance. Strict security compliance dictates that the virtual machines must send telemetry to Azure Monitor exclusively over the Azure Backbone network, avoiding the public internet completely. What is the first resource you must create to establish this private connectivity? Compare the following options. Option A is a private endpoint. Option B is a log analytics workspace. Option C is an Azure Monitor Private Link Scope, AMPLS. Option D is a data collection rule, DCR. In this case, select option C. An Azure Monitor Private Link Scope, AMPLS. This is correct because to route telemetry traffic from a VNet privately to Azure Monitor, you must configure Azure Private Link. The foundational resource for configuring Private Link with Azure Monitor is the Azure Monitor Private Link Scope, AMPLS. You create the AMPLS first, associate your monitoring resources to it, and then create a private endpoint on the VNet that links to the AMPLS. The incorrect choices fail for the following reasons. A. The private endpoint is created after the AMPLS is established, as the endpoint must connect to the AMPLS. B. While a log analytics workspace is required to store the data, creating the private networking boundary specifically requires establishing the AMPLS first. D. A data collection rule dictates what data is gathered, not how the network traffic routes securely over the Azure backbone. Remember this distinction for the exam. When restricting Azure Monitor traffic to a VNet via private link, always create the Azure Monitor Private Link Scope, AMPLS, before creating the actual private endpoint. Let us work through question number 38. Begin by examining the scenario. A storage account contains a blob container named Data Archive and an Azure file share named User Profiles. In the same region, Vault A is a backup vault and Vault B is a recovery services vault. You must configure scheduled Azure backup protection for both workloads. Select the appropriate vault for each workload. Choose the correct entry for every drop-down field. Statement 1. Data Archive, blob container the blank. The available choices are 1. Vault A only, Vault B only, Vault A or Vault B, or cannot be backed up to either. Statement 2. User Profiles, file share the blank. The available choices are 2. Vault A only, Vault B only, Vault A or Vault B, or cannot be backed up to either. For Statement 1, select Vault A only. Azure Blob Operational and Vaulted Backup are managed by a backup vault. For Statement 2, select Vault B only. Azure Files Backup is configured through a Recovery Services vault. Keep this examination point in mind. Choose the vault from the protected workload, Recovery Services Vault for Azure Virtual Machines and Azure Files, Backup Vault for Azure Blobs and newer workloads. Apply precise reasoning to question number 40. We are moving to Entra License Management. Identify the decisive requirement in this scenario. A Microsoft Entra tenant contains these groups: HRSEC, assigned security group containing users Sales 365, Microsoft 365 Group IT Dynamic, Dynamic User Security Group Devices Dynamic, Dynamic Device Security Group. You want to assign Microsoft Entra IDP2 licenses by using group-based licensing. To which groups can you assign the user licenses? Eliminate any option that fails a requirement. Next, option A, HRSEC only. Next, option B HRSEC and Sales 365 only. Next, option C HRSEC, Sales 365, and IT Dynamic only. Next, option D. All four groups. The appropriate choice is option C HRSEC, Sales 365, and IT Dynamic only. The key reason is group-based licensing can target security groups and Microsoft 365 groups that contain users, including dynamic user groups. A dynamic device group has devices rather than users and cannot receive user licenses. The other choices do not satisfy the requirement because A and B, these omit a supported dynamic user security group. D. Devices dynamic contains devices, so user licenses cannot be assigned through it. Exam tip. Group-based licensing applies licenses to user members. Security groups, Microsoft 365 groups, and dynamic user groups are suitable, device-only groups are not. Let us examine question number 41. Let us first review the situation. An Azure subscription contains a storage account named Data Lake 1 and an Azure Synapse Analytics workspace named SynWorkspace A. You are configuring automated pipelines in Synapse. The workspace's managed identity must be able to read, write, and delete blobs inside the containers of Data Lake 1. Which Azure RBAC role should you assign to SynWorkspace A at the storage account scope? Choose from the following options. Choice A, Storage Blob Data Contributor. Choice B, Storage Account Contributor. Choice C, Reader and Data Access. Choice D, Contributor. The best answer is option A, Storage Blob Data Contributor. Here is the technical justification. The Storage Blob Data Contributor role provides exact data plane access required to read, write, and delete blob data within a storage account container. The remaining options are incorrect because B, Storage Account Contributor provides management plane access, managing the storage account resource, keys, network settings, but does not grant direct data plane access to read or write blobs. C, Reader and Data Access is a management plane role that allows getting account properties and storage keys, but it does not allow Microsoft Entra identity-based data access. D, Contributor is a management plane role and lacks data plane rights for blob manipulation. Roles with data in the name, for example, Storage Blob Data Contributor, grant data plane access. Roles without it, for example, Storage Account Contributor, grant management plane access. Evaluate question number 43. Against every requirement. Pay close attention to every stated constraint. A storage account named Store99 contains box 1/file1.txt, box 2/file2.txt, and box 3/file3.txt. Mark has storage blob data reader with a role assignment condition that allows read actions only when the container name equals box 1. Sarah has storage blob data owner with a role assignment condition that restricts write actions to blob paths containing the character 2. Her condition does not restrict read actions. For each statement, select yes if the statement is true. Otherwise, select no. The first statement is, Mark can read the blob in box 2. The second statement is, Mark can read the blob in box 3. The third statement is, Sarah can read the blob in box 1. For the first statement, choose no. Mark's read condition permits reads only in box 1. For the second statement, choose no. Mark's read condition also blocks reads in box 3. For the third statement, choose yes. Sarah has the owner data role, and her condition restricts only write actions, so read access remains allowed. A useful examination rule is this. In an ABAC condition, first identify which actions the condition applies to. Permissions for other actions continue to follow the assigned role. Proceed to question number 44. Scenario. NIDA, NetB, and NetC are fully peered. VMA is in NIDA, VMB is in NetB, and VMC is in NetC. VMC is a reachable custom DNS server at 192.168.0.5 and hosts corp local with an A record app 1.corp local equals 10.10.10.10. NIDA uses Azure-provided DNS NetB and NetC use 192.168.0.5 as their custom DNS server. The virtual machines have renewed their DNS settings after the VNet configuration changes. For each statement, select yes if the statement is true. Otherwise, select no. Statement 1. From VMA, app1.corp local resolves to 10.10.10.10. Statement 2. From VMB, app1.corp local resolves to 10.10.10.10. Statement 3. From VMC, app1.corp local resolves to 10.10.10.10. Statement 1. The answer is no. Azure-provided DNS and NIDA does not automatically query the custom zone hosted on VMC. Statement 2. The answer is yes. NetB sends the query to VMC, and VNet peering provides network reachability. Statement 3. The answer is yes. NetC also uses VMC as its DNS server, which is authoritative for corp local. The key takeaway is VNet peering does not propagate custom DNS settings. Configure each VNet or forwarding path explicitly and renew client DHCP/DNS settings after changes. Question number 46. Highlights an important distinction. The central scenario is as follows. You manage two single container images, ImageWin, Windows Server Core ImageLin, Ubuntu Linux. You are evaluating Azure Container Instances, Azure Container Apps, and Azure App Service Custom Containers. Select all services in the list that natively support each image operating system. Review each blank and choose the most appropriate option. The first statement reads, ImageWin can be hosted on the blank. Choose between 1. Azure Container Instances only, Azure Container Apps only, Azure Container Instances and App Service only, Azure Container Apps and App Service only, or Azure Container Instances, Azure Container Apps, and App Service. The second statement reads, ImageLin can be hosted on the blank. Choose between 2. Azure Container Instances only, Azure Container Apps only, Azure Container Instances and App Service only, Azure Container Apps and App Service only, or Azure Container Instances, Azure Container Apps, and App Service. Statement 1 should be completed with Azure Container Instances and App Service only. ICI and App Service support Windows containers. Azure Container Apps requires Linux container images. Statement 2 should be completed with Azure Container Instances, Azure Container Apps, and App Service. All three services support Linux containers. Remember this distinction for the exam. Azure Container Apps uses Linux container images, use ACI, App Service, or AKS when a Windows container runtime is required. Let us work through question number 47. Begin by examining the scenario. An Azure App Service web app named Portal App runs in a standard app service plan. An Azure Key Vault named CertVault contains a supported PKCS12 wildcard certificate. You have owner access to both resources and must import the Key Vault certificate into Portal App and bind it to a custom domain. What must you configure first so that App Service can import and synchronize the certificate? Now examine the possible answers. Option A is grant the Key Vault certificate user role on CertVault to the Azure App Service resource provider. Option B is enable a system-assigned managed identity on Portal App. Option C is grant yourself the Key Vault secrets user role. Option D is upgrade the App Service plan to Premium. The required response is Option A, grant the Key Vault certificate user role on CertVault to the Azure App Service resource provider. The reasoning is as follows. For App Service certificate import, the App Service resource provider must be authorized to read the certificate from Key Vault. With Azure RBAC, grant it the Key Vault certificate user role on the vault. B. The Web Apps Managed Identity is used when application code accesses Key Vault, not for the App Service Resource Provider certificate import operation. C. Your personal data plane access does not authorize app service synchronization. D. Standard already supports custom TLS bindings, premium is not required. Keep this examination point in mind. Importing a Key Vault certificate into App Service authorizes the Microsoft Web/App Service Resource Provider, not the Web Apps Runtime Managed Identity. You have completed Part 1 of the AZ-104 Microsoft Azure Administrator Exam Practice Series. Keep building your Azure administration skills by opening the complete playlist and continuing with the remaining parts in sequence. If this session helped your preparation, like the video, subscribe to Tech with Kaushik, and enable notifications for more certification exam practice content. Share your score, doubts, or feedback in the comments. I would be happy to hear how your preparation is going. Thank you for learning with Tech with Kaushik. Keep practicing, and I will see you in the next part.